Before we try to do any of the types of problems involving the hypothesis test of one mean, where the population standard deviation is unknown, I want to walk you through the process of this. And it's the same 5 steps that we've been looking at, except there's going to be a little bit of change in steps 3 and 4 when we go through and construct the distribution, and then also in being able to compute not the p-value but the test value. Okay, first step, null alternative hypothesis. Okay, those are still going to be the same as the one mean test where the population standard deviation is known. Remember, we always assume that the sample mean is going to be equal to the population mean. Okay, so if I know that the average GPA of a Hartford Community College student is 2.63, then if I take a sample of 100 students, that GPA should be 2.63. The alternative, one of 3 possibilities: x bar less than mu, x bar greater than mu, x bar not equal to mu. Step 2, we always want to collect the variables. Okay, the variables are going to be a few more than last time, and we're also going to have to utilize the calculator to be able to get some of the variables. Okay, so we need mu, which is our population mean. In our calculators, we're going to compute x bar and s. Okay, so these are going to be the calculators. Okay, or calculations that we get from a calculator. And I posted instructions on Blackboard as to how to get these from the one-var stat. So you're going to have to use the one-var stat function. Okay, so make sure you look at the video in announcements to be able to get those. All right. The other things we're going to need n, the sample size, we're going to need the alpha level, and then the last new variable that we need is we need the critical value. Now, t critical is going to be found by the alpha level, or if it's a two-tailed test, alpha over 2, and then the degrees of freedom, which are n minus 1. All right, so a lot of the data collection is going to be the same. We just have to work a little bit harder to be able to get both x bar and s. And again, we're going to use our calculators to get those. Third step, we always draw the distribution. Now the distribution is going to be a little bit different than what we're used to because we're going to be now working with the critical value method. Okay, so this is a significant difference from the method that we've been looking at before. If it's a right-tailed test, okay, so I'm just going to draw all 3 of these out. If it's a right-tailed test, the range of values on the t distribution are negative to positive infinity. T critical is going to be at the right tail, and 0 bisects the distribution. Okay, so again, this is a t distribution, not a normal distribution. Also, this is used when the alternative hypothesis is x bar less than mu. If it's a left tail test, so if for some reason we had x bar less than mu, then this is the distribution we would be looking at. So we have our distribution. It's a left tail. The range of values is still the same, negative infinity to positive infinity. 0 bisects, but the left tail, or the cutoff region, is now negative t critical. Okay, so that's important. Okay, so we're just going to have to take the opposite of whatever we get for t critical. And this is, I made a boo-boo here. Okay, so if we can go back, this should be for a right tail test. So I apologize. This should be if x bar is greater than mu. And then for a left tail test, this is when x bar is less than mu. Okay, so I do apologize about that. So nothing's different except for the cutoff as well as the range of values. Okay. Finally, for a two-tailed test, we are still going to have the same method. Okay, so here's our distribution. Right. We have 2 tails. We have negative infinity to positive infinity for the distribution endpoints. We have 0, and then the left tail is minus t critical. The right tail is positive t critical. However, and that's for not equal to mu, However, we have to remember that before we find t critical, we are going to have to split alpha. Okay, so we are going to split alpha before finding t critical. All right, so that's important. Otherwise, we're going to get the wrong values when we go through and try to find the cutoff regions. All right. So let me try that again. T critical. There we go. All right. Instead of getting a p-value, now what we're going to do is we're going to be able to get something called a test value. All right. So for the test value, now we're just going to call the test value t, not t critical. The formula is going to look familiar. X bar minus mu divided by, instead of sigma, s over the square root of n. Just like we did before, we're going to put those in parentheses. All right. And usually what we do is we convert that to a p-value. Now in this case, we just get the test value and we stop. Okay, so once you get t, you do not convert this. Okay, so once you get your test value t, you do not convert using a table. Well, that's not. All right. So when you get t, you do not convert at that point. All right. 5. Conclusion. Okay. Conclusion is the same as it was before. So if the test value falls in the reject region, then you reject the null. Okay. So test value in reject. This means that you reject the null. And then if the test value is in the fail to reject region, this means that you fail to reject the null. All right. So go back through this, make sure you understand the process before we go through and work a few problems, okay? You will need your calculator, and you will need to make sure that you can use the one-var stat function. So before you go through and try to look at an example, it may be helpful to watch the videos as to how to compute x bar and s using the one-var stat function. And those videos should be in the announcements file.